to achieve those goals, we're going to follow this pretty straightforward design. At least I think it's straightforward. Essentially what we have here is we have a solar panel that charges a 6-volt battery, and we have a charge controller circuit which makes sure that we safely charge the battery, and once the battery has charged up to a certain level, the circuit slowly stops charging so we don't overcharge and damage anything. And then when the battery drains, the circuit starts up again, keeping the whole system running. Then for the brains of our unit, we have an Arduino Pro Mini. Then for the brains of our system, we have an Arduino Pro Mini, which will be running some custom C code that will manage our entire system. To measure the moisture in the soil, we have a capacitive soil moisture sensor, which sends an analog signal to our Arduino, which then measures it and decides whether or not to turn on the pump or leave it. For user input, we have a single variable resistor, which is basically just a knob that the user can turn to make the environment more moist or more dry. To reflect the level that the user has chosen, we have 3 blue LEDs, which increase from right to left and also intensity to reflect, do I want a more wet environment? All the lights will be turned on fully bright. Do I want a more dry environment? Maybe only 1 or 2 of the lights will be turned on and they'll be more dim. Additionally, for user feedback, there is a multicolored LED which reflects certain states of the system. It turns red when the environment is too dry. It turns blue while it's pumping. It turns back to green when the desired conditions have been met. And if for some reason the solar panel has been out of the sun for days, for too long, and the battery is draining, it'll blink orange to let the user know that something's not quite right and you need to intervene and maybe change the position of the solar panel. So this is essentially how the circuit is going to function. And now let's move on to the build process.